Hi students, today we'll learn how to solve single variable inequalities. These are like solving equations, except instead of an equal sign we have inequality symbols. When you solve an inequality, there is one rule you have to remember. When you multiply or divide both sides of the inequality, by a negative value, it does not apply if you're multiplying or dividing by a positive value, then you must always remember to flip the direction of the inequality symbol. So if you have a less than, you would flip it to a greater than. If you have a greater than equals, for example, you would flip it to a less than or equals. We'll do some examples in a minute that'll show you when to use this rule. Here's a reminder of what each symbol is called. We have less than or equal to, greater than or equal to. When you're solving an inequality, you're not finding the one value of the variable that makes both sides true like in an equation. You're solving for all the numbers that make it true. So our answer won't be one number, it might be all the numbers less than another number, or all the numbers greater than or equal to another number. We represent the solutions on a simple graph on a number line. So in this set of notes, we'll not only be learning how to solve these inequalities, but also how to graph them to represent the solutions. For example, on less than, we indicate the number that it's less than with an open circle on that number, and then we would shade everything to the left of that open circle. For less than or equal, we would have a closed dot on that number that it's less than or equal to, and then we would shade everything to the left that's less than or equal to that number. Greater than is the opposite. Greater than, again, will have an open circle on the number that it's greater than, and then everything to the right will be shaded. For greater than or equal to, we will have a closed dot on the number that everything is greater than or equal to, and then everything to the right, or that's greater than that number, will be shaded. These ways of graphing on the number line work when your variable is on the left side of the inequality symbol. If you solve it and it's on the right side, I'll show you how to flip it around so that you're able to graph it. But we'll do lots of practice. So we have 8 examples that we're going to solve, and then I'll show you how to graph them on the number line. Remember, it's just like solving equations. The only thing you have to remember, that extra rule that only applies if you're multiplying or dividing both sides by a negative number. And in that case, we'll flip the direction of our inequality symbol. Let's take a look at number 1. You can draw your line under the inequality symbol just like you would if you were solving an equation. You're trying to get the variable by itself. Generally, you want to try to get it by itself on the left side, but if it ends up on the right side, I'll show you what to do. Since our y is already on the left side for number 1, we'll just leave it there. We just have to get rid of that minus 2, and we'll get rid of it by adding 2 to both sides like we normally would. When I add 2 to negative 2, that goes away. Now I have y. I want to bring down my exact symbol, which is less than, and then 6 plus 2 is 8. So my solution is all values of y that are less than 8. Y is less than 8. So any number that's smaller than 8, if I go back up to the original equation and I replace y with any number less than 8, it will make the left and right sides true. It'll make the left side be less than the right side. So to graph it, Mrs. D just wants you to do 2 numbers on your graph. You always want to have 0, and then you want to have the number that you're less than, greater than, or less than, equal, or greater than, or equal to. On the number line, negatives are on the left, positives are on the right. So I'm going to put the 8 on the right. I don't need to include all the tick marks. We can make a simple graph. For a less than, I want you to remember that's an open dot. Open dot, do not fill it in. That means we're not including the number 8. We're just including numbers less than or right up to 8. And then we're going to shade everything to the left. So when your variable is on the left side of the inequality symbol, the symbol will actually point in the direction that you shade. That's why we're shading to the left. Okay? All right, let's try another one. Number 2, to get that p by itself, we're going to get rid of that -8. This is usually looks like the last step when we're solving inequalities. So we're going to divide both sides by that -8. And put a little star here. Remember, if you divide or multiply both sides by a negative, we've got to flip the direction of our symbol. So let's remember that. So -8 divided by -8 is 1. 1 times p is p. But instead of bringing down a greater than symbol, I'm going to flip it to a less than symbol. -32 divided by -8 is +4. So my solution are all values of p that are less than 4 will make that inequality true. So on our graph, we need to put a 0. We need to put the number 4, which is positive, so it's to the right of 0. Because we have a less than, we're going to have an open dot. We're including all numbers right up to 4. And then we will shade all the numbers that are less than 4, which are to the left of 4. All right, as soon as you feel like you're getting the hang of this, feel free to pause the video and try some of these examples on your own, then unpause and see how you did. Number 3, we've got to get our variable by itself, that a. We got to get rid of that 12 and that 3. We're going to get rid of the 12 first because that's a constant. We're going to subtract it from both sides. I'm going to bring down 3a, bring down the greater than, 18 minus 12 is 6. Now some students right here might get confused and think, oh, that's a -12. I've got to flip my symbol. Well, that's only if we're multiplying or dividing, and it's only if it's a negative. So I'm just subtracting. I'm not multiplying or dividing, so we're not going to flip our symbol. Next step, get rid of that 3. We're going to get rid of that by dividing. Notice I'm dividing by a positive, so I don't need to flip my symbol either. So a is greater than 6 divided by 3 is 2. So the solution is all numbers that are greater than 2. So on my graph, I've got to put 0. I've got to put the number 2. I've got a greater than symbol, so that's an open dot on 2. This time, my symbol points to the right, so I'm going to shade to the right. Number 4. We need to get all our variable terms on one side. So let's move that 10t to the left side. And because it's positive, we will subtract both sides by 10t. Okay? 10t minus 10t is 0. 9t minus 10t is -1t. We still have the +5. We have a less than or equal to symbol. And we have a -3 on the right. Now we've got to move our constants to the other side. So to move that 5 over, we're going to subtract it on both sides. 5 minus 5 is 0. I've got -1t on the left equals -3 minus 5 is -8. Now I've got to get rid of that -1 coefficient. We're going to get rid of that by dividing. So I'm dividing both sides by a -1. Put your little star to help you remember, hey, I got to flip that symbol. And look at what Ms. D put. I put an equal sign instead of a less than. It's habit. Make sure you're constantly focusing on those symbols. -1 divided by -1 is +1. 1 times t is t. But because we divided by a negative, I've got to switch that less than equal to a greater than or equal to. And -8 divided by -1 is +8. So our solution is all values of t that are greater than or equal to 8. So I'm going to go ahead and put 0 on my graph. 8 is positive, so it goes on the right. This time I've got the little equal sign under my symbol, which means my dot is not going to be open, it's going to be closed. That means that 8 is part of my solution, whereas in the other examples, my solutions were only up to those numbers. Because my symbol is pointing to the right, it's a greater than, I'm going to shade to the right. All right, we got a few more. Let's draw our line. This time we have parentheses, so we're going to distribute that 7 to the a and to the -1. So we've got 7a on the left, bring down your less than, 3. Now let's distribute. 7 times a is positive 7a. 7 times negative 1 is negative 7. All right, now we're going to clean up that right side by combining like terms. We can combine the 3 and the negative 7. That makes negative 4. Bring down everything else. We've got a positive 7a on the right, got a less than, we've got a 7a on the left. Now we want to get all our variable terms to the same side. Let's move them to the left. To move that 7a on the right to the left, we're going to subtract 7a on both sides. 7a minus 7a is 0. 7a minus 7a is 0. So I've got 0 on the left is less than negative 4. Oh dear, this looks like one of those weird examples, those special cases we did before. If your variables disappear, look at what you've got going on. This says 0 is less than negative 4. Is it true or false? If it's false, like it is here, because 0 is bigger than negative 4, that means we have no solution, which means there is no value of a that will make that left side of the inequality less than the right side. So if there's no solution, there's no graph. Okay, let's try number 6. Again, we've got parentheses, so we're going to distribute that negative 5 to the x and to the 3. Negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. Bring down your less than symbol. We've got negative 5x on the right and plus 1. Now we're going to get our variable terms on the same side. Let's move that negative 5x on the right to the left by adding 5x to both sides. When I add 5x to negative 5x, I get 0, and that's the same on both sides. So just like number 5, my variable terms have disappeared. Let's bring down what we have left and see what we got going on. We've got a negative 15 on the left. We've got a less than symbol. We've got a positive 1 on the right. So let's think about this. Is this true or false? Is negative 15 less than 1? It is true. So because it's true, that means, you guessed it, that we have infinitely many solutions, which means any value of x will make this inequality true. And again, you can write IMS if you'd like, infinite many solutions. Now to graph infinitely many solutions, you can put your 0 on your number line, but you're really going to shade in the entire number line, because every single number on this number line will make this inequality true. Number 7, if you look closely, you have 2 inequality symbols. This is actually called a compound inequality because it's basically like 2 inequalities in one. Negative 7 is less than or equal to 2x plus 1 is one inequality, and 2x plus 1 is less than 9 is the other inequality. Because they both share the 2x plus 1, they've just put the less than 9 on one side and the negative 7 is less than or equal on the other side. So this is kind of an interesting case. To solve this, you're going to put 2 lines down. If you have a compound inequality like this, your goal is to get that variable by itself in the center, in the middle. We kind of have 1, 2, 3 sides instead of the 2 sides that we're used to. So we're going to see what happens here. Okay, so to get that x by itself in the middle, I've got to get rid of the plus 1 and the 2. We're going to get rid of the plus 1 first because that's our constant. So to get rid of that plus 1, I'm going to subtract it from each side, and this time I've got 3 sides to subtract it from. So when I subtract 1 from 1, I get 0. So in the middle there, I only have 2x. I'm going to bring down both my symbols, my less than equal and my less than. On the left, I've got negative 7 minus 1, which is negative 8. On the right, I've got 9 minus 1, which is positive 8. We're going to keep going. To continue to try to get x by itself in the middle, I've got to get rid of that 2. We're going to get rid of that 2 by dividing each of those 3 sides by 2, by the same number. 2 divided by 2 is 1. 1 times x is x. Bring down your less than and your less than or equals. On the left side, negative 8 divided by 2 is negative 4. On the right, 8 divided by 2 is 4. So our solution is this. Now what does that mean? It means two things. There's two parts to it. One of the solutions is x is less than 4. That's one part. The other solution is negative 4 is less than or equal to x. I'm going to rewrite that. Negative 4 is less than or equal to x. Now I said before we graph it, we've got to have x on the left side of the inequality symbol, not the right, like it is. So if I switch the x and the negative 4 to get x on the left, that's great, but I also have to flip my symbol. So let me do those two things. I'm going to put x on the left, negative 4 on the right, and I'm going to switch that less than or equal to greater than equal. So my other solution is x is greater than or equal to negative 4. So I have two solutions. X is less than 4 and x is greater than or equal to negative 4. So we're going to graph both parts. Put your 0. Positive 4 is to the right, negative 4 is to the left. I don't care about the tick marks, but both of those numbers need to be on there. So for the first one, x is less than 4, we're going to put an open dot on 4, and we're going to shade to the left, but not yet. On the other one, we have x is greater than or equal to negative 4. That's a closed dot on negative 4, and it's pointing to the right, so we're going to shade to the right. We are going to shade the parts that they have in common. I'm going to shade to the left of positive 4, but to the right of negative 4. So I'm actually just shading the place between those two. So this is called a compound inequality. Okay? All right, let's try another one. This one is just a very long inequality. So this one is not compound, but it does require a couple steps. We can do this one if you'd like. If you'd like to fast forward and not write this one down, that's fine. But there are 5 word problems at the end of this, at the end of these notes that are real important that I do want you to write down. All right, for number 8, we've got 3 sets of parentheses, so we're going to distribute 3 times. 5 times k is 5k. 5 times 4 is 20. Negative 2 times k is negative 2k. Negative 2 times 6 is negative 12. Bring down the greater than. On the right, 5 times k is 5k. 5 times 1 is 5. And then we have a minus 1. So now we're going to clean up each side. We've got a lot of terms on the left and right we can combine. On the left, we can combine the 5k with the negative 2k to make 3k. We can combine the 20 and the negative 12 to make positive 8. Bring down the greater than. On the right, we can combine the positive 5 and the negative 1 to make positive 4. And then, of course, we'll bring down that 5k. All right, both sides are cleaned up. Now we want to get our variables on the left side. So we're going to subtract 5k from both sides because I want to move the 5k from the right to the left. 5k minus 5k is 0. 3k minus 5k is negative 2k plus 8 greater than 4. Now we want to move our constants to the other side. To move that 8 over, we're going to subtract it because it is positive. 8 minus 8 is 0, so I've got negative 2k on the left is greater than 4 minus 8 is negative 4 on the right. Last step is get rid of that negative 2. To get rid of that, I have to divide both sides by a negative 2. Don't forget, we've got to flip the symbol. Negative 2 divided by negative 2 is 1. 1 times k is k. But instead of bringing down a greater than, I want to bring down a less than. Negative 4 divided by negative 2 is positive 2. So our solution is k is less than 2. Put your 0 on your graph. Put your 2 on your graph. Because it's less than, that's an open dot. And because it's less than, we're going to shade everything to the left. All right, we're about to do a couple word problems. Sometimes there are phrases in word problems that can clue you in as to certain symbols. For example, if you see at most, or you see maximum, you want to include a less than or equal to symbol. Okay, so that's a key right there. If you see the phrase at least or minimum, then you're most likely going to include a greater than or equal to symbol. The less thans and greater thans are going to be words that kind of sound like that, maybe smaller than, less than, greater than, bigger than, those kind of words. So let's take a look at some word problems. For these word problems, we're going to first write the inequality and then we're going to solve. Okay, so let's see what this one says. Albert earns $3.50 for each hour he works. If he wants to earn at least $52.50, how many hours must he work? Remember, at least is a greater than or equal to symbol. So we know in our inequality we're going to have greater than or equal to 52.50. So what is greater than or equal to 52.50? The amount that he earns. Well, he earns $3.50 for each hour. So that's going to be $3.50 times the number of hours he works. So here is our inequality. $3.50 times our variable is greater than or equal to $52.50. So he's got to earn more than how many hours to make at least $52.50. So let's go ahead and solve this inequality. It's a very simple one. We're just going to get rid of that $3.50. That's a coefficient, so we're going to divide both sides by $3.50. $3.50 divided by $3.50 is 1. 1 times x is x. Greater than or equal to, and let's pull out our calculator, 15. And remember what x represented. X is the number of hours. So, as long as he works more than or equal to 15 hours, he will make at least $52.50. All right, the daily production cost for Escape Factory cannot be more than $5,400. If it cannot be more than, then that means it's got to be less than or equal to that $5,400. So that's going to be part of our inequality. More than would be greater than. The opposite of greater than would be less than or equal to. It says it costs $15 in materials to make each pair of skates, and the daily operating costs are $900. So to be less than $5,400, we have $900 in operating costs plus $15 for each pair of skates. So X is going to represent how many pairs of skates we need to figure out. So we're going to go ahead and solve this inequality. So to do that, we need to get that X by itself on the left. First, let's get rid of that 900 by subtracting it from both sides. So 15x is less than or equal to 5,400 minus 900 is 4,500. To get rid of the 15, we're going to divide both sides by 15. So x is less than or equal to 300 pairs of skates. And those are pairs. So as long as they make less than 300 pairs of skates, they will not spend more than $5,400. So less than or equal to 300, and I'll put pairs of skates because they always come in pairs. A group of 3 friends went to the movies. After paying for their tickets, they had a total of $10 to spend on refreshments. That means they can spend no more than $10. They may spend less than or equal to $10 because that's all they've got. Sodas cost $1.50 each. A box of popcorn costs $1.75. How many sodas can they buy if they purchase 2 boxes of popcorn? Well, 2 times a box of popcorn, which is $1.75, plus $1.50 per each soda, we'll call sodas X's, will help us to figure out how many sodas they can buy. So let's go ahead and solve this inequality. Let me write it down right here. 2 times $1.75 plus $1.50 times X is less than or equal to $10. Okay, 2 times $1.75 is going to be $3.50 plus the $1.50 for each soda. They still got to spend less than $10. So to solve for X, first we got to get that $3.50, the constant, to the other side. So we're going to subtract $3.50. We're subtracting out the $3.50 for the popcorn, right? And I'm going to move my equation down here. So I've got $1.50 for each soda. It's got to be less than the difference after I buy that popcorn. So 10 minus $3.50, I've got $6.50 left. Now we're going to divide both sides by that $1.50 to figure out how many sodas we can get. We can get less than or equal to $6.50 divided by $1.50 is about 4.3 repeating, or 4 1/3. I can't buy 1/3 of a soda, so as long as they buy less than or equal to, let's say, 4 sodas, then they'll be good. So they can get up to 4 sodas with the popcorn under $10. I know this video is getting a little long. If you'd like to skip number 4, example 4, you can go straight to example 5. But this is a good example that'll help you determine what you need to get on your final exams each semester. So Kevin's semester grade in history will be determined by the average of twice each of his 3 6-week averages and his final exam score. He earned a 76, an 85, and a 74 for the 3 6 weeks. He needs to get an average of at least 80. At least is greater than or equal to receive a B. What is the minimum grade? Remember, minimum is also greater than or equal to make on his final exam. So when they average your semester average, they're counting each 6 weeks twice. So 2 times 76 plus 85 plus 74 plus your final exam. That makes 7 grades in total. 6 for 2 times each 6 weeks plus a final exam. So this is your inequality, and rather than rewriting it, I'm just going to circle it and draw an arrow. To solve this is going to take a little bit more time. What we need to do is we need to first get rid of that 7 at the bottom, so we're going to multiply both sides by 7. So times 7, multiply this whole side times 7. The 7 up here and the 7 down here cancel. So what we have left, and I'm going to try to simplify it as we go, is 2 times all of that. Those 3 averages add up to 235, and then when I multiply it by 2, we get 470. So this part right here is 470. I'm just going to rewrite that. 470 plus x is greater than or equal to, and then 80 times 7 is 560. All right, so now what we got to do to get that x by itself is just subtract all of his 6 weeks grades added up times 2 minus 470 on both sides. So x is greater than or equal to 560 minus 470, which is a 90. So what this means, he has to get greater than or equal to a 90% on his final exam in order to keep a B in that class. And this is how you can actually figure out what you need to make on your final exams. This last example is we're not making an inequality to solve. We're actually going to be setting up a compound inequality. Here's what it says. On an interstate highway, the maximum speed is 70 miles per hour and the minimum speed is 45 miles per hour. If x represents speed, then write an inequality to express this condition. So if you recall back on number 7, that was also a compound inequality. We're going to have something on either side of x that's going to represent the speed that he needs to stay between. Maximum is less than or equal. So there we have a maximum or a less than or equal of 70 miles per hour. Minimum is greater than or equal. So we're going to have greater than, here I'm going to write it down here, greater than or equal to that 45 miles an hour. However, to make a compound inequality, I want the x in the middle of the two inequality symbols. So if I want to get that 45 at the start of my compound inequality, I'm basically flipping the x and the 45, which means I also have to flip this symbol, which is going to be another less than or equal to. Now we're not going to do a whole lot with this year, but you may see this more in geometry. The way this reads is the miles per hour, or the speed, has to be between 45 and 70. So that's kind of what this means. This 45 is the low end, 70 is the high end. We have a less than or equal in both spots here. All right, that's it. That was a lot of notes. Good job. I'll see you in class.